All right, so this first question is an ASVAB question. Just keep in mind that when you're doing this on the ASVAB, you will not be allowed to use a calculator. So you don't have to write down the entire question, but the main thing I want you to write down, of course, on the Bell Work packet is the date, which is Monday, October 14th. So we're going to go 12 miles. If a car is towed 12 miles to the repair shop and they charge you $3.50 per mile, how much does the tow cost? So on the ASVAB, you would not be allowed to use a calculator. So this would be an example of a question where you would want to round. So what does $3.50 round to? $4, yep. So what I would do if I were taking this test is I would round this to 4. And then I would just multiply 12 times 4. So then I would take 2 times 4, which is 8. And then 4 times 1, which is 4. Now, we don't see that as an answer choice because we rounded it. But what you can do is pick the answer closest to 48. All right. So what answer choice, A, B, C, or D, is closest to 48? Who would say A? B? C? Yeah, C. So that would be my recommendation, again, because if you are taking this on the ASVAB, or you're not allowed to use a calculator. So I would do rounding, approximate. This is called an estimation, and use that. All right, so let's get to our notes. Go back to your bright yellow packet and flip over to page 2. In our bright yellow packet. And we're going to do pages 2 and 3 today, and then we will be finished. So we're going to talk about polynomial functions by graphing. So the value of x when y equals 0 are the solutions of the function. And they're also the x-intercepts. Can't quite fit that in there. But x-intercepts is what I'm trying to put on that line. So you're asked on this pages 2 and 3 for your x-intercepts and your solutions. Just remember that that's the same thing. So this means that the solution must equal 0 before you graph it. All right, so let's go ahead and look at example 1. So first of all, it's asking you for the x-intercepts. Show me with your fingers how many x-intercepts do you see? How many times does this graph go through x? I agree, 3 different times. It crosses here, here, and here. So my x-intercepts would be at, where's that first blue dot? -3. And then the next blue dot would be at -1, and then the last blue dot is at +2. So that means that my x-intercepts, which I'm going to write as ordered pairs, would be at -3, -1, and +2. Now, when we're talking about our solutions, though, our solutions, that would just be x is equal to those numbers. So x equals -3, -1, and 2. Factor form, every time you see a 0, we have to put a parenthesis. So because we have 3 solutions, let's make 3 parentheses. So 1, 2, 3. Put an x in front of each one. So this is going to be y equals, and then you have your 3 parentheses. Now, does anybody remember what we have to do with our signs when we go from here to here? This was on the test. Isaiah, we got to flip it, yeah? So do you see how our first one is at a -3? So you're going to put a +3 in the first parentheses. Then our second parentheses, we're going to put a +1. And our third parentheses, we're going to put a -2. Now, because our arrows are opposite, we know this is an odd degree function. And remember, we look at the right arrow to see if it's even or odd. Right arrow. That would be this arrow. If because it's going up, I know that this is a positive function. So this is my right arrow, and this is my left arrow. So on the left side, let's talk about the left. What is it doing? On the left side, does everyone see how it's going down? So that means we're going to put a negative infinity. But on the right side is going up. So we're going to put a positive infinity. All right, if you look at this backboard, I try to explain this the best I can. But first of all, your domain for every single function is going to be all real numbers. Okay? Every time it's asking you for a domain, you're going to write all real numbers. If it's an odd function, meaning the arrows are opposite, then your range is also going to be all real numbers. So anytime it's an odd degree function, the domain and range is all real numbers. So we can write that for both. Every odd degree has a domain and range of all real numbers. And that is it. Any questions? All right, let's look at example 2. Show me with your fingers, for example 2, how many x-intercepts do you see for this graph? How many times does it cross? Yep, good job. 4 times. So we have here, 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 and here. All right, so my x-intercepts would be at -3, 0, -1, 0, +2, 0, and +5, 0. Remember, these are the same question, except for the solution, I'm going to write x equal. Instead of an ordered pair, I'm going to write that as x equal. So my solutions would be at x equals -3, -1, 2, and 5. All right, so we have y equals, give yourself a little bit of space after the equal sign, make your 4 parentheses. Because there's 4 zeros, so we need 4 parentheses. Put an x in front of each one. And remember, we're going to flip the sign. So for the first one, instead of a -3, I'm going to put a +3. And then instead of a -1, I'm going to put a +1. Instead of a +2, I have a -2. And instead of a +5, I have a -5. Now, do you think this is even or odd? Even, because arrows are the same. So I'm going to write that just in case you don't remember. Remember, if the arrows are the same, then we call that an even function. And both arrows are going down. So this is an even negative. Now, let's go back to factor form. Because it's a negative function, anytime it's a negative function, we have to put a -1 in front of our first factor. So go back, And we only have to do that for a negative function. Put that -1 in. So anytime it's negative, we have to put that -1 in. All right, now both arrows are going down, so my end behavior is going to be the same. And because both arrows are going down, we're going to say negative infinity for both. All right, our domain, again, all real numbers. Now let's look back at this backboard. Because this is an even negative, everybody look back here. Because it's even and negative, which means both arrows are going down. When you write your range, you're going to write it as y is less than or equal to, and it's going to be your highest y value. So my range is going to be y, and then put a less than equal to. Now, when I go to the graph, see how I have two mountaintops? The highest mountaintop would be right here. So we got to approximate, what do you think that number is? It's a number between 50 and 75. 70. Now, we could say 70, you could say 65, you could say any number as long as it is between 50 and 75. Okay? Because we don't really know what it is because we don't have enough information. So we will say y is less than or equal to 70. That'll work. Any questions? All right, let's go to the next page and finish it out. Let's look at example 3. Show me with your fingers how many x-intercepts do you see? Let me see something real quick. Yeah. Okay. How many x-intercepts do you see with this one? 5. Yeah, there's a lot. So first of all, we got opposite arrows, so we know this is odd. Let me go ahead and write that. And we have 5, so I'm going to put 5 sets of parentheses. Okay, so when I look at the graph, we got one here, 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 and here. So that would be -2, -1, 0, 1, and 2. So those are my 5 x-intercepts. So -2, 0, -1, 0, 0, 0, 1, 0, and 2, 0. So my solutions would be x equals -2, -1, 0, 1, and 2. All right, so let's write our factor form. So we got 5 zeros, so we need to put 5 parentheses. And remember, you flip the sign. So we got a +2. We have a +1. Now this one, because it's 0, I'm just going to leave it by itself. You really have 3 options for that middle parentheses. You can leave the x by itself, or you could put a +0 or a -0. But adding 0 and subtracting 0 is the same thing as x. So I'm just going to leave that middle one by itself. And then I have the x -1 and I have x -2. So because this side is going up, see how it goes up? That means that my leading coefficient would be positive. Now the left side goes down, so that would be negative infinity. The right side goes up, so that would be positive infinity. This is odd, so my domain and range is all real numbers. All right, any questions about that? Okay, last one. All right, so how many x-intercepts do you see with this one? 3. So we have one here, here, and here. So we have a -3, 0, a +2, 0, and a +5, 0. So x equals -3, 2, and 5. All right, so factor form. Now this is a little tricky. So we got to make our 3 parentheses. We're going to put our x in front of all of them. And then flip the sign. So instead of a -3, it's a +3. Instead of a +2, it's a -2. And instead of +5, it's -5. So now, but let's look at this graph though, because this graph is a little different. So right here, do you see how it bounces? Whenever it bounces off of the x-axis, that means your factor is squared. So go ahead and write that. If it bounces off the x-axis, that one is squared. So that means that this x -2 that you see right here, that's really twice. So we just put a 2 on the outside of that factor. So it bounces. Right here, it went through, and here it goes through. But here it comes up, hits the 2, and bounces back. It bounces. So is this an even or an odd degree function? Even, yep, because its arrows are in the same direction. They're both going up, so it's positive. So my end behavior is positive infinity, left and right. So even functions have the same behavior on both sides. Our domain is all real numbers. And if you look at the backboard, anytime it's even and positive, this is how you're going to write your range. So your range would be y. And then this time is greater than and equal to. We got to look for the lowest point. So my lowest point would be about here. So what is y equal right here? -4. That would be your range. All right, let's talk about the homework. You can now do all of homework 1. So pull out homework 1. It was originally due tomorrow, but I thought that was kind of mean since we just got back. So I moved it to Wednesday. So go ahead, write that on your homework 1. Most of first period finished it and turned it in today. So I would encourage you to just do it and get it done. Now in the homework 1, do you see how in that first line it says identify the zeros? That's the same thing as solutions or x-intercept. All right, so go ahead and work on homework 1, and if you finish it, turn it into the blue tray before you leave.